We are live now. We are live. We are live. We are live. We are live. Now, my dear friends, what is happening? What is happening? What is happening? We are live now, my dear friends. I hope. I hope you are all doing fine. I hope you are all doing fine. I hope you are all doing fine. So today's topic is De-Broglie hypothesis. Today's topic is De-Broglie hypothesis. So we are gonna do this. Do this today. De-Broglie hypothesis. De-Broglie hypothesis. This is what we are going to do today. This is what we are going to do today. Yes, today. This is what we are going to do. So first, first, let me tell you about myself. First, let me tell you about myself. My name is Raghav Sharma. As you can see me, Raghav Sharma has a 3+ years of teaching experience, done MSc Physics, BSc Physics, B.Ed, published an international journal in Journal of the American Ceramic Society, has done research work with researchers in JNU Jawaharlal Nehru University. So this is all about me. This is all about me. And this is first, do tell me, how's the preparation of the exam going on? How's the preparation of the exam going on? If it is going bad, then rate it 1. Rate 1. If it is going okay, then rate it 2. And if it is going fine, very good, excellent. If it is going very good, fine, excellent, and you can say, I will achieve my dream college. If you can say that I can achieve my dream college, then rate it 3. Then rate it 3. So it's on you. So it is going 1, it is going 2, or it is going 3. 1, 2, 3. It's on you. So this is what we are going to do today. This is what we are going to do today. Photoelectric effect and particle nature of effect of light. First we are going to discuss this thing. Okay. From that, then we will discuss wave nature of light, wave nature of matter. Then we are going to discuss wave nature of matter. Now that is important stuff. Wave nature of matter. From the exam perspective, that is important. We will going to do that completely. And after this, we will do previous year questions. We are also going to do previous year questions. Okay. Without previous year question, the subject is like incomplete. Subject is like incomplete. So we are going to do that also. But before starting all these things, make sure you have joined our channel NEET in what? In Telegram. Okay, this is the symbol of what? This is the symbol of Telegram channels, like pen, paper, no, paper plane, Ishak. So this is the symbol of Telegram channel, and our channel name is NEET, ALT, where we provide PDF materials, free classes, do announcements, and do crazy stuff too, and also give you discounts, prizes, and giveaways. We are going to do some giveaways of the material stuff that you will like. So make sure you are in our channel on the NEET. After this, make sure you have subbed our channel, mean you have subscribed us. Okay, because subscription is important in YouTube. Okay, so Here we post regular, you know, stuff that is in fiery stuff. We do post regularly fiery stuff here. So make sure you have subscribed us on what? On the YouTube channel. On the YouTube channel. And now let's talk about little bit of about our course. Little bit about our course. What we do, we provide 90 plus concentrated and concise classes on the NEET that is important to our what? To our course. Nothing here, nothing there, concise and concentrated on the NEET. After that, we have convenient educational platform. What does that mean? That you can see me on, phone, laptop, PC, Android, iPhone, whatever the device you have. You can also see me on tablet, because on that stuff on which you can say internet can, you can access internet, that in that I can, hello Avinash, hi hi Avinash, hi Avinash. After this, hi again, and syllabus from my and my team, from Vishnu sir, from Pratyaksh, and from myself and other members too. Good evening, good evening. Happy Republic Day, Happy Republic Day. Okay, so Happy Republic Day, Happy Republic Day, Happy Republic Day, Happy Republic Day. So syllabus made from the NEET experts. We have also flipped classroom method that is unique in India, and I am going to discuss that in detail on later. Okay, I'm going to discuss that later in the video. Later in the video, and we have doubt solving practice. Okay, we have we have groups in WhatsApp, and you can just share your question and we will give you solution. We have experts sitting. Okay, and I am also sitting there. So we have doubt solving practice, and that is live. So some will, if you have the doubt in physics or in chemistry or in biology, our faculties are sitting, and I'm also sitting, and our all other faculties are also sitting. So they are going to solve your doubts live. Okay, so and they are going to solve them, and we have faculty our another faculties too. So I think that is a good stuff if you have faculties. And this is our how our plan looks like. We have three plans: light, smart, professional. Let me drink some water. Okay, let me drink some water. Tomorrow I have done classes, back to back, and my throat is like, oh. Yes, yes. So we have three plans: light, smart, and professional. On light, smart, professional, you are going to assess those four stuff. You have interactive live classes. Okay, we are doing the classes, and structures, course, and PDFs. You are going to get that, and you are going to get many things more. You are going to get many things more. Uh, Good evening, Mariam Fatima. Good evening, Fatima. So we have structures, course, and PDF. Just ask me, I will give you the PDFs of whatever thing you want. And then we have live test, and we have physical notes. What more you want? After that, we have one-to-one mentorship. Okay, in both smart and professional, live doubt solving. We have mock test. Okay, this three, we have this three stuffs we have in both smart and professional. And if you want personal inspiration, so that we have in professional. If you want inspiration, you are going, no, I am low in inspiration. So if you add that on your plan, you will have the motivation too. And if you don't have motivation, we will give you. Okay, we are we are going to continuously give you motivation on that. So on smart, we have mentorship, live doubt solving, mock test. So we have three plans: light, smart, and professional. let's get started. Now let's get started to our topic, that what you are waiting for. So first, let's talk about photoelectric effect and particle nature of light. What is photoelectric effect and particle nature of light? Before photoelectric effect, what we are doing before photoelectric experiment, what we are doing, till then, we are saying light has what we are saying, we are saying that light has, we are saying what, that light has wave nature. We have saying that light has what, only wave nature, and it has backed by various experiment, and it has backed by various experiments, like we have interference, young double slit experiment, very famous experiment on that. I think you have all done this experiment on your physics lab in school. Diffraction and polarization of light. I have done that experiment in my school time. I don't know that you have done them or not. They are basically very easy experiment and fun experiment to do. Interference, diffraction, polarization. Very, very, very interesting. Okay, when I was in school, uh, the teachers, say let's do that, and we just this distance doing that thing in groups. So in groups, everything is interesting. Okay, in groups. So we used to do that stuff in groups. But I haven't done group study ever, because in group study I haven't done any study. In group study I haven't done any study. I have done experiment groups, but not ever group study. So they have shown what? They have shown what? They have shown what? They have shown wave mechanics. They have shown what? Wave mechanics. They have shown what? Wave mechanics. What we are doing till now, we are just saying that light has only has what? Wave nature. And we have experiments to back this up. And you have also done this experiment on your school lab. Interference, diffraction, polarization. Okay. We know it. What happened? What changed the things? What changed the things? What thing has happened that changed the things? The thing that has happened, that is photoelectric effect. The thing that has happened, that is photoelectric effect. And that phenomena can't be explained by what? Wave nature of light. That thing can't be explained by wave nature. Can't be explained by wave nature. And what are the things? Now you will ask me, sir, tell me, what are the things in photoelectric effect that can't be explained by wave nature of light? What are the things that can't be explained? So first thing, that kinetic energy of photoelectrons is independent of the intensity of light. Kinetic energy of photoelectrons, the electrons that are emitted in what? In photoelectric emission, is independent of what? Intensity of light. What that mean? Let's say first explain it in the basis of wave nature. Okay, let's say we know by the experiment we know that it is independent. But if we see on what? On the wave nature. Okay, if light is a wave, imagine if light is a wave. Okay, if light is a wave, then on increasing intensity, what should happen? What should happen? Amplitude of what we imagine, that light is electromagnetic wave. We imagine that now, that light is electromagnetic wave. So if we increase the intensity, the electric field and magnetic field amplitude should increase. Yes or no? Okay. So the intensity should be directly proportional to what? Amplitude square. A square, A square, A square. Then the electron on metal surface, then what will happen? The electron on metal surface will experience what? Greater kinetic energy. They will experience what? They will experience greater kinetic energy. Force electric is what? E into E, and force magnetic is what? Q into V cross B. So these are going to increase, and similarly the amplitude is going to increase. So what will happen if we increase the intensity? If we increase the intensity, the individual, the electrons that are emitting, their kinetic energy should increase. Their kinetic energy should increase. If we increase the intensity, are you getting me? If we increase the intensity, kinetic energy should increase. But that thing is independent. So this thing of wave nature that say about increasing intensity, the kinetic energy should increase, is wrong. That first statement is wrong. So this thing is wrong. Okay, that thing is wrong. Are you get? Do you get it? Do you get it? If we increase the intensity, and light is what? Electromagnetic wave. So the magnitude of force electric and force of magnetic Fe and Fv should individually should increase. Okay, and if they increase forces, we are increasing the force. We are increasing the what? We are increasing the force. So overall, if we calculate the amplitude of Fen plus Fe and plus Fm, F electric plus F magnetic, they should increase. If force is increasing, the amplitude should also increase. But that thing is increasing? No. Okay, if we increase the force, kinetic should increase. But that thing is not increasing on experiment. Okay, on experimentally, when we have done that kinetic energy is not increasing with what? With intensity. So that stuff is wrong. So the first reason is that, okay, that say that it can't be explained in wave nature. Second reason, existence of what? Threshold frequency. What did it say? Let's say if light is a wave, if light is a wave, okay, then even if light of low frequency is incident on a metal surface. Let imagine this is a metal surface. Okay, and here are some free electrons, let's select red. They are free electrons. If we do just incidental low frequency what? Wave. According to wave nature, they should absorb this energy and immediately get out from what? Get out from the metal. But is that thing happens? No, that don't happen, because there is a existence of what? Threshold frequency. The electrons keeps absorbing energy. And ultimately overcomes what? Work function. Experimentally we have seen that. Okay, so a minimum amount of energy, or a minimum amount of what? A photon of some threshold frequency is needed to overcome this what? Barrier. Okay. And according to wave frequency, according to wave nature, that shouldn't has to happen. Any light, any intensity of light, if it's going to strike, it should just emit. It should be emitted. This thing is said by what? Is said by the wave nature. But that thing doesn't happen. There should be a minimum energy, photons of the minimum, or you can say of some threshold frequency has to be there. Okay. So reason number 2, that there is an existence of threshold frequency. So this thing is can't be explained by what? By the wave nature. Wave nature say what? Any frequency of light, if it is incidenting, there should be an what? Photoelectric emission. But that thing is not happening. So in this thing, wave nature is also wrong. Wave nature was also wrong. Third reason was instant ejection of photoelectron. There is an instant ejection. Okay, like cut se aaya, cut se gaya, like immediately coming and immediately going out. There is no time gap. Okay, there is no time gap between them. Coming and going. Photon come, electron strike, and then go. What wave nature? And now this is by the experiment. By the experiment, we have seen there is no time delay. But by wave nature, what it say? It should absorb some light. It is a wave nature, so it should keep on absorbing some energy. Then it will then after some time, it will have some sufficient energy. And after getting sufficient energy, it will go out. So there should be according to wave nature, there should be some time delay. But by experiment, what we have seen, that there is no time delay. And photon came, electron absorbed and gone out this whole thing is happening on an instant. No time delay. By experiment, we have seen that. But according to wave nature, there should be some time delay. So again wrong. Three things wrong. Three reasons. Kinetic energy of the maximum kinetic energy of photoelectrons is independent of what? Intensity. Second, existence of what? Threshold frequency. And third, there is an instant ejection of photoelectrons. So we have three reasons why that photoelectric emission is not a wave nature but a matter, but because of matter, it shows a that nature, matter nature. So then there came De-Broglie. Okay, I have written this in punk style. De-Broglie, and he gave a hypothesis. Wave nature of matter. Matter's wave nature. There are two. Matter has its other nature. Matter has its natures. Wave has its natures. What he just jointed the both stuff. He said wave nature of matter means the one that are seeing me right now also has the wave nature. Okay, Mariam and Avinash also has wave nature. Me, Raghav Sharma, has also the wave nature. Everyone in the world has the wave nature. This thing was said by none other than De-Broglie. De-Broglie said everything has wave nature. Everything has wave nature. Everything has wave nature. Okay, everything has wave nature. So again, going to repeat some stuff. Going to repeat some stuff. Okay. So after the photoelectric effect, it was well known that radiation in light has both the nature. What are the natures? Wave nature, wave nature. That is also had wave nature, and it also has what? Particle nature. That is also has particle nature. For wave nature, we have some experiments like interference, young double slit experiments, diffraction, polarization, and for the particle nature, we have photoelectric effect, we have black body radiations, and we have Compton effect. We have Compton effect. So we have both the stuff. We have both the stuff. So after the photoelectric effect, we know that it has also this natures and also has this natures. What De-Broglie had done, he said that it has that wave has what, wave has what, matter nature, particle natures. So this and also this. Okay. And according to him, we can consider that we should study this thing by the wave or particle nature. Okay. When we are doing some stuff, so there are two theories. One theory is of the particle nature and one theory is of wave nature. So he said, according to the what experiment, we can consider that what should consider, wave nature or particle nature. Particle nature. So in 1924, in 1924, now we are coming in a important stuff. So in 1924, De-Broglie put a hypothesis. Now he's put up a hypothesis. He said first, nature is what? Nature is symmetrical. Symmetrical. Okay. Is the spelling right? Symmetrical. Symmetrical. It is symmetrical. Okay. Another, he said, light, or you can say any radiation can behave as what? Can behave as particle. Any radiation or any light can behave as what? Particle. Or he said one thing also, light, if radiation can behave as a particle, so particle can also behave as what? Can also behave as a wave. Okay. Nature symmetrical, light, particle, wave. Okay. And after this, he has done one thing, and he got Nobel Prize for that. Okay. That guy has a Nobel Prize. That guy has a what? That guy has a Nobel Prize with him. What he said, every moving particle. He said what? Every moving particle have a wave associated with it. Wave associated with it. And bingo. After this statement, he got what? He got Nobel Prize. After this statement, he got what? He got Nobel Prize. What he said, that every moving particle have a wave associated with it, and he got what? He got Nobel Prize. If particle has wave, that it will have some wavelength. So the every particle that is moving with some velocity, every particle that is moving with some velocity will have a wave associated with it, and have the wave, have some lambda wavelength, and have some wavelength. Okay, you know what is wavelength. So every particle that is moving have some what, have some wavelength associated with it. And for that statement, that guy got what, Nobel Prize. Okay, that guy got what, that guy got Nobel Prize. So make sure you also do some comment, so you can get what, Nobel Prize. uh, I am new to the class. Okay, everyone is new, everyone is new. Okay, everyone is new. And if you are new, that you will one day become old in class. Okay, so new and old, sure, just we are doing things. Okay, we are just getting started, we are just warming up, so you are not late. Okay, you are not late, we are just starting the things, we are starting the things. So that guy got Nobel Prize on the statement, every moving particle have a wave associated with it, and if it's a wave associated with it, it will have what, it will have some wavelength. Okay, so the wavelength of such moving particle, will be given by lambda h upon p, where p is what, momentum, where p is what, momentum. H is what, Planck's constant. H is what, Planck's constant. H is what, Planck's constant. Lambda is what, wavelength. For this formula, that guy got what, Nobel Prize. Okay, that guy got Nobel Prize. So lambda is equal to h upon mv. Important. That thing is important. Okay, that thing is important. So make sure you have this formula in your heart. Make sure you have this formula inside of your heart, like forever. And h value, Planck's constant value, I think you all know it. 6.626 10 raised to minus 34, and I think the unit is joule second. 6.626 10 raised to minus 34 joule second. H value, m is the mass, v is the velocity. And now what can you do? You can put the value of h, you can put up of your mass. Okay, let's say your mass is 50 kg and you are running with this velocity. Put all in an SI and just calculate what is your wavelength. Try to do that. Okay, very important, very interesting, what is the wavelength of me, of sir, or of anything. You can calculate the wavelength of anything. Okay, for heavier particles, such waves are called what? Such waves are called matter waves. So anything which have mass, have some velocity. And you also have matter waves. I also have matter wave. Everything has matter wave. If it is moving with some velocity, it will have some what, wavelength, and wave associated with it. And that wave is called as what, matter wave. That wave is called what, matter wave. That wave is called what, matter wave. Now let's discuss for heavier particle. Okay, for heavier particle, yes, no, we have questions. So let's say for heavier particle, do we have after this? Yes, we will do this later. First, let's do the question. Let's first do the question. Question time. Question on this formula. Question on this formula. Which of the following figures represent the variation of particle momentum and associated De-Broglie wavelength? We have the formula. And if we plot lambda versus momentum, what it is going to be? Is it going to A? Is it going to B? Or is it going to C? What it is going to be? H is constant. So lambda P is constant. Lambda into P is constant. Or you can say lambda is inversely proportional to the momentum. Then what is going to be? Is it going to A like this? Okay, C directly no, exponentially no. B and C are wrong. Is it going to be A or is it going to be D? What is it going to be? Yes, it is going to be D. Yes, you are right, Vikas Kumar. You are right. If we plot this, it will be like this. Answer D. Rectangular hyperbola. Okay. Rectangular hyperbola. Let's say the stuff that we are doing. Let's do the stuff that we are doing. After this, we will do, I have lots of questions. But first, let's do this. Let's say for heavier particles, like if you say your lambda, my lambda, the bus lambda, the train lambda, the aeroplane lambda, if we find those lambdas, okay, let's say for example, something has a mass of 0.1 kg and its velocity is 20 meter per second. And if you find lambda associated with it, what it will be? 6.6 10 raised to 34, 0.1 raised multiplied by 20. What will be the wavelength? It will be 3.3 and 10 raised to minus 34 meter. Okay, or you can say 3.3 10 raised to minus 24 angstrom. Okay, 3.3 into 10 raised to minus 24 angstrom. Just see how much small this is. So for heavier particles, it will be good if you consider what? Particle nature, not the wave nature. Because the wavelength is so small. 10 raised to minus 34 meter. Just imagine how small it is. 3.3 raised to 10 raised to minus 34 meter lambda. For heavier particles, lambda is so small that it cannot be measured. But for subatomic particles, like say for electron masses 9.1 10 raised to minus 31 kg. Okay, and its velocity, if you done the atoms chapter, you know its velocity is around 10 raised to 6 meter per second. If you find lambda for this, it will come out as 7.33 angstrom. I'll skip the calculation part, written it like this, 7.33 angstrom. Just see, this is 7.33 angstrom and that was 3.3 10 raised to minus 24 angstrom. Just imagine how much the difference is between wavelength for the subatomic particle and for what? And for heavier particle. We can measure it, lambda is significant, but for heavier particle, lambda is what? Insignificant. Okay. In terms of kinetic energy, lambda is what? H by P. That stuff is easy. Kinetic energy is what? P square upon 2m. P will be what? 2mk. Just put this, lambda is h upon under root 2mk. Done. Done. Okay. Done. 2mk. Done. 2mk. Where k is kinetic energy, m is the mass of the particle, 2's value is 2, and h value is h. Planck's constant. This is lambda. In terms of what? In terms of kinetic energy. In terms of what? In terms of kinetic energy. Now let's do a question. Pretty easy question to do. An electron of mass m and photon have some energy E. Energy is going to what? Energy is mostly is like kinetic energy. Okay. After this, the ratio of De-Broglie's wavelength associated with them. We have a mass electron and we have a photon, and we want to find the ratio of De-Broglie's wavelength of them, which have the what? Which have the same energy. Can you do that? We want to find what? Lambda p upon lambda, sorry, electron is first. Lambda e upon lambda p. This is what we want to find. Can you do that? Easy question. When I will do it, it will look like it will look like very easy. When I will do it, this will going to be look very easy. Okay, let's do it. For electron, okay, for electron, energy is what? E. Let's say electron energy is E. Let's make goodie. For electron of energy E, both have what? Same energy. E. De-Broglie value will be lambda E h upon 2me. Any doubt how we get that? H by P. P is 2mk and k here is E. Mostly energy is going to be what? Kinetic energy. So 2me. So lambda is h upon 2me. Okay. Photon energy is also E. Photon energy is also E. Also E. Okay. And it is what? H mu. Or you can say hc upon lambda p. We have lambda E now, we have lambda P now. We have lambda E and we have lambda P. What we have to do? We just have to take ratios. Now what we have to do? We just have to take ratios and we will have our answer. Lambda E and we have lambda P. Lambda P will be hc upon E. Okay. We have 1, we have 2. We have to find this lambda E by lambda P. So lambda E, let's put the lambda E. We don't have any space. Let's do here. Lambda E h upon 2me. What about lambda P? Lambda P is hc upon E. Okay. We will going to cut some stuff. H cut. There will be 1 by C, and E under root E will come up upon 2m in under root. So this will be what? This will be lambda E upon lambda E. This is going to be lambda E upon lambda P. Pretty easy stuff. Lambda E upon lambda P. 1 by C E by 2m raised to half. And the right answer is I think B. 1 by C E by 2m. E by 2m. No. E by 2m. C. C is the right answer. E by 2m raised to half. So C is the right answer. What I have said, when I am going to do that, that is going to look very easy. That it will look very easy when I am going to do that question. So correct answer is C. See, just see how have I done that? How have I done that? After this, we have another question. We have another questions. Can you do that? Another very easy question. If the kinetic energy of the particle is increased 16 times its previous value, we have increased the kinetic energy by 16 times, then the percentage change in De-Broglie wavelength will be. If we increase the energy by 16 times, then what will be the increase in what? De-Broglie's wavelength. De-Broglie wavelengths. We know that lambda is h upon 2m a. We know it. We know it. So this is the condition 1. In next condition, lambda dash, when we increase the kinetic energy 16 times, this will be h upon 2m 16k, and 16 will come out outside. Under root 16, this will be 4 2m k, and this will be, this is lambda. So lambda dash is nothing but lambda by 4. So wavelength decreased by 4 times. Okay. So what is the percent change? I can just answer it without doing another calculation. It is 75%. But calculation percent change, that you should know how to find it. Percent change lambda, okay, amount of change versus original multiply by 100, like delta lambda upon lambda into 100. Okay, percent change, you all know the formula. So lambda upon lambda dash, this will be lambda minus lambda by 4 upon lambda multiply by 100. This will be 3 by 4 multiply by 100, and this will be 75%. This is going to be 75%. Percentage change is 75%, not 25, Vikas Kumar. 75. We have to find percent change. Okay, percent change formula, delta lambda, how much is change upon the original, multiply by 100, sorry. So lambda minus delta lambda, initial lambda, final lambda dash. So percent change will be what? Percent change lambda minus lambda dash. And originally it was what? It was lambda. So delta lambda upon lambda multiply by 100. Lambda dash lambda by 4, lambda minus lambda dash by 4, 3 lambda by 4, lambda cut, 3 by 4 multiply by 100, 75%. Any doubt in this stuff? Any doubt? I think it is a pretty easy thing. You can just find percent change is easy, bro. Percent change is easy. After this we have lambda in terms of accelerating potential. Means in terms of v. Accelerating potential like this. Okay, negative, and this is positive. Zero potential v. So delta V is V, delta V is V. And kinetic energy, according to, we know that in previous lectures I have done that kinetic energy K is equal to Q delta V. So kinetic energy is K, kinetic energy K is Q, delta V is V. Difference in potential K equal to QV. Now we have to do this. We know that lambda is H upon under root 2 mk. And K is what? K is what? QB. K is what? QB. What no? What no, Vikas Kumar? Vikas Kumar, what no? Do tell me your doubt. I will clear that. What no? What no? What no, my dear friend? What no? So K is QB, just write and I will clear your doubt. What no are you signifying? K equal to QV. K equal to QV. So H 2m QV lambda. In terms of what? In terms of accelerating potential, we have the formula H upon 2m QV. 2m QV. 2m QV. 2m QV. Lambda is what? 2m QV. Okay, 2m QV. And if we do we have another page? No, we don't have another page. Where should we do another? Try to do that here. Okay, let's do. Let's say for famous example, for electron, Q is what? E. Q is what? E. So lambda is what? H upon 2me upon V. 2me upon V, where m is the mass of electron, E is the charge of electron, H is Planck's constant. And if we put the value of all the constants, so lambda will be what? Lambda will be 12 by 27 upon under root V. This is going to be when V, lambda is in angstrom and V is in what? Electron volt. Okay, let me write it somewhere. Okay, so V lambda is 12 by 27 upon under root V. Okay, lambda in angstrom in this condition, and V is in electron. Or you can say lambda is equal to under root. Do this. Okay, I think it's enough. Okay, so this is for electron. For NEET, I think it's enough. We don't have to go in more detail. Clear, my friends. Now it's question time. Now we are going to do questions. Do read this question. NEET 2020 question and NEET 2021 questions is very much easy. So let's try to do NEET 2020 questions. 22 is you will see that question, you will laugh. So 2021 questions. An electron is accelerated from rest through a potential difference of V volt. If the De-Broglie's wavelength of the electron is this, De-Broglie wavelength is this, the potential difference is, we have to find the V, and the formula is for electron. We know that lambda is 12.27 under root V. Okay, and lambda is in what? This is in angstrom. And this V, and this V. Okay, this V is in volt. Okay, this thing is in volt. This V is in volt. Okay, this V is in volt. Sorry for that. So we have to find V. We have the lambda in nanometer. We have to convert that in what? We have to convert in angstrom. In angstrom, this lambda will be what? 0.1227 angstrom. Put this value here and just find V. So under root V will be 12.27 upon this lambda will come 0.1227. 0.1227. Okay. If we cut that, what will come? 100 will come. 12.27, 0.1227, 100. V will be 100 square. That will be 10 raised to 4 volt. That will be 10 raised to 4 volt. NEET 2020 question. Lambda equal to 12.27 and root V. We have to find. Lambda is 0.1227 angstrom. Put in that value in the question, solve it, and we find the V is equal to 10 raised to 4 volt. V raised to 10 raised to 4 volt. Another question. Let's do 2019 question. Let's do 2019 question. Same question. An electron accelerated through a potential difference. Another electron. Okay. Electron. So we can just apply this lambda E, or can we say lambda? Lambda is equal to 12.27 under root V. Again we can do that. And we are going to do that. Okay. What do we have to find? We have to find the De-Broglie wavelength. And V is what? 10,000 volt. V is 10,000 volt, or you can say 10 raised to 4 volt. Okay, 1 2 3 4, 10 raised to 4, 12.27 under root 10 raised to 4. Okay, this isn't going to be an angstrom. So lambda will be 12.27 under root upon 100, 10 raised to 4. 10 raised to 4. If we remove the under square, this will come 10 raised to 2, 10 raised to 100, 12.27 upon 100 angstrom. So that will come at 0.1227 angstrom, or you can say 1.227 nanometer. Answer is in what? Answer is in what? Answer is in meter or nanometer. Answer is meter, and we have to find in meter. Let's find in meter. In nanometer it is not matching. Let's find in what? In meter. Let's find it in meter. So this will be 0.1227 raised to 10 raised to minus 10 meter, or we can say 12.227 10 raised to minus 12 meter. 12.27 10 raised to minus 12 meter, and 12.2 C is matching. 12.2 10 raised to minus 12. 10 raised 12.2. Okay, he just eaten up the 7. He just eaten up the 7th thing. Okay. After this, we have question this. Another easy question. NEET 2017. We have NEET 2017 question. NEET 2017 water is also. Okay. NEET 2017. So the question is the De-Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T Kelvin mass is. What is asking? the de-Broglie wavelength of neutron in thermal equilibrium with water. You know, that will look like very, tough questions. If you just read the statement, this will look like, oh, what he is given, and this will look like, so, oh, very tough question. How will I do it? But actually, this is a very easy question, and there is a derivation inside it. Just see the solution very carefully. Is asking for the de-Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T and mass m is. Okay, just do it. So kinetic energy of neutron in thermal equilibrium with heavy water that is heavy water at a temperature T is given as okay. I have written the statement, but I have just written this 3/2 kT. You all know it from the kinetic theory of gases. K is what? 3/2 kT. This K is small, okay? This K is small. This K is kinetic energy, this K is constant. This K is small, 3/2 K, and this T is temperature. Is 3/2 kT. 3/2 kT. Kinetic energy is, and momentum is what? Momentum is what? 2 mk. 2 m. This K is kinetic energy. Put this value of K here. So 2 m and K 3/2 K small k E 2 cut, and that will momentum will come out as 3 m constant K E. This K is small k, okay? This K is small k. 3 m kt. Momentum we got T/2 kt. And then what will be the wavelength? Wavelength is what? H/P. H and P is 3 m kt. 3 m k T. De-Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T and mass m is H/3 m kt. 3 m by kt. H upon 3 m by kt. Just we have put on the value of kinetic energy is in equilibrium T/kt. And we got the solution H/3 m kt. I think pretty easy question. After this, let's try to do this question. NEET second phase 2016. NEET second phase 2016 question. NEET second phase 2016 question. Electron of mass m. You know the language. Don't get scared by the language. Okay. The questions are easy. Questions are on their own are easy. Language sometimes they make like, oh, this is something. This is going to be something tough. But in reality, okay, reality is different. The questions are easy. Questions are easy and pretty easy to do. Just see this NEET question. This will look like, oh, this is something. This is going to be tough question, but questions are easy. Let's now do the question. Electrons of mass m with de-Broglie wavelength lambda fall on the target in an X-ray tube. Okay. Electrons of wavelength lambda of target. Okay. We have to find the cutoff wavelength of the emitted X-ray. Cutoff wavelength. Photoelectric effect. Cutoff wavelength. What is cutoff wavelength? Hc by lambda naught. What is okay. We have to find the lambda naught. This is what we want to find. Okay. This is what we want to find. So let's first find the maximum kinetic energy. Let's find the kinetic energy of electron. Let's find the Kinetic energy. Kinetic energy is what? P square by 2m, and P according to De-Broglie is h by lambda. H by lambda square upon 2m. So this will be kinetic energy will be h square lambda square 2m, or you can say h square 2m lambda square. K will be this. K will be this. So this is the maximum energy that a photon can have. Topic potential is what? Inverse of it. Topic potential is what? Cutoff frequency. Sorry. Cutoff wavelength. Cutoff wavelength is what? Hc by lambda naught. Hc by lambda naught. Hc by lambda naught. What is that? Phi upon lambda. Phi upon lambda naught. Phi upon lambda naught. Phi is Hc. Lambda naught is what? Lambda naught is what? Cutoff wavelength. This is the cutoff wavelength. Cutoff wavelength. We have done that in what? We have done that in what? In photoelectric effect. Phi values Hc, lambda naught, and that is equal to this. That is going to be equal to this. That is h square upon 2m lambda square. That is going to be equal to that h square upon 2m lambda square. Now we have to find the lambda naught. Now we have to find the what? Lambda naught. So 1h cut. So lambda naught upon c, just inverse the stuff. So 2m lambda square upon h. So the lambda naught will be 2m c lambda square. C will come here. We inverse that. 2m c lambda square, and this is h. Okay, this is actual h. This is h. So 2m c lambda square upon h. This is going to be our answer, 2mc lambda square upon h. Let's see if I'm matching or not. 2mc lambda square upon h. A. Pretty easy stuff. Okay. So let's talk about flipped classroom method. Now let's talk about flipped classroom method. So what is that method? First, we provide you what? Theory. We provide you what? Theory and previous year question paper and some conceptual questions. In physics, that what I do. First theory plus PYQ and plus some conceptual questions. I think that much is enough. After this, we will provide you study material also. PDFs and some PDFs we provide you of the various topics, study materials. After study materials, if you have some doubts, then we can have we have webinars, we have faculties. Okay, now I'm talking about the one-to-one mentorship. So we have faculties that are sitting, and I think that much can clear your doubts. And we have homework. We provide you homework to do. What is homework that you do at your home? Lockdown is running on, so what more can you do? You can only do homework. The anything that you are going to do is going to be homework. Anything that you are going to do is going to be homework. Then our faculties are sitting that are going to check your homework, that you have done good or you have done your wrong, and going to make your profile and going to call you if you are doing good, and if you are going to bad, they are going to just notify you that how are you doing right now. If you are going good, and they will say yes, you are doing good. If you are doing bad, then they are going to give you some suggestions, timetable, and all that stuff. This is all about one-to-one mentorship that we have. So this much stuff we generally do: theory, study materials, webinars, homework checking, and then meeting with you in phone call, on Zoom, that anything that you like. So this is how our classes is going to look like. After this we have reached to the conclusion. So see you soon. And you can scan that thing. Okay, you can scan that thing. And that will take you to our what, Telegram channel, I think. Or I think again to the YouTube channel. I think it is going to get you to the Telegram channel. If you scan this thing, take the screenshot, scan this, and you can join our uh, Telegram channel. Okay. See you. Goodbye. Tata. Sayonara. Bye bye.